Meet Violet. Every day, you can find her putting miles on her toy trucks. It doesn't matter if it's a teddy bear, a doll, or a stack of building blocks. Deliveries need to be made. And Violet is the only one who knows how to get them from point A to point B. At SAE International, giving students like Violet the chance to experience, collaborate, and think about ways to move society into the future is what motivates all we do. Because we know that in a few years, she'll be showing her little sister how she built the winning jet toy car for Mr. Murphy's 6th grade science class. And a few years after that, she'll be working with her college classmates to build their very own self-driving car, which in turn will lead to a job as a junior and then lead engineer for an autonomous trucking company. The SAE STEM programs, which start in pre-K and go all the way through college, will put Violet on a path of discovery, innovation, and inspiration. While it might just be playtime for now, we know that someday Violet's going to walk confidently into her office. Deliveries will need to be made, and she'll be the one making it happen. Good luck, Violet.
Hey everybody, Mark Z here. Today we're in Sterling Heights, Michigan. We're taking Supercharged on the road right here in the heart of Detroit Manufacturing Center. There's Detroit Arsenal down the street here, the GM Tech Center, and today we're at the Advanced Manufacturing Commercialization Center, which is actually part of an organization that SAE International runs. So we're going to go inside and meet Mark Pickett, and he's going to tell us all about it.
Ingersoll actually manufactured this machine for the Army. This is a pilot scale. It is a friction stir deposition machine. So the ram at the top accepts metallic billet in rod form, and it drives down to the mixing head at the bottom inside the chamber, and it will spin that billet and create frictional heat. It plasticizes the metal and allows it to flow. Very unique about this technology is it does not melt the metal, so you don't have to worry about outgassing, you don't have to worry about changing the physical properties of the metal. And quite honestly, the mixing capability of this machine creates a microstructure that's more mixed than it was as a billet, which is important in terms of if you cut a printed part, cross-section of a printed part, you would not be able to differentiate the lines in the different layers. It would be uniform. This is called a print coupon. So you print on this base, and you print whatever part from CAD, and then you cut off, or you machine it, you final machine it, and then you cut the coupon off and you have your final part. This machine does both additive and subtractive. So it has a mixing head that lays down metal, and it has a subtractive head that does a final machining.
Mark, how long would it take to make a component like that? Is it a day process, or is it faster?
It's faster than that, depending on the material you're working with, the geometry of the part you're trying to create. I know that the large machine can print up to 40 pounds an hour.
Oh.
So this is a pilot scale machine that was put here to develop the manufacturing processes and also could potentially treat additive manufacturing data to inform standards. But this machine will be used to inform Rock On and Arsenal, who has a machine that is probably 10 times the size of this machine.
Oh, wow.
With a print envelope of 16 feet by 20 feet by 30 feet, they will print a combat vehicle hull at scale with no seams.
Very Star Trek-ish.
Yeah.
Wow.
Here right now is this tractor bed. You can see the bit at the end. And then there are some trial parts. So this machine was installed earlier this year, went through first article test, was qualified, and now they're starting to iron out the manufacturing process. Right, standard operating procedure.
Is there, so this machine is a commercially available machine?
It is a one-off customized machine that is the mechanical structure that holds the heads and moves them around. It runs on rails. That itself weighs 100,000 pounds.
So with this located in Detroit or Metro Detroit area, this is one of the few places in the world where this technology comes together, right? SAE is integral into this, and the SAE government group that you are working with brings the government side together and the commercial side together. And talk about commercialization for a second.
Sure.
Because that's part of your mission here.
Right. The initial project in scope is to support the Army program at Rock On and Arsenal, but long-term success looks like bringing other government agencies. We already have interest at the Air Force and the Navy. We have industry interest as well, not only with defense primes, but also some of the automotive and aerospace companies, and then collaboration with universities for R&D work. The government wants this to exist outside the wire at the Detroit Arsenal to attract companies and other government agencies to come here to collaborate because they want to develop advanced manufacturing techniques that then become commercialized. They don't want to create a specialized manufacturing technique that's only applicable to defense because you can't leverage the economies of scale with techniques like that.
Right.
But if you can commercialize it, then the government benefits by the economy of scale.
So Mark, what else is on the menu here for you? You've got a lot of space here. What's the next exciting gig you're gonna?
There's another additive manufacturing technique called laser powder bed fusion. And those three crates right there contain other types of additive manufacturing equipment for metallic part builds. They each have a little bit different capability. And those three machines, once funding comes from the government, they will be installed here. And then the rest of this space is open for collaboration. Purchaser, capability, and machine.
This guy over here looked like there was a little oops here. What happened with that?
This is an armor application.
Ah.
And so what they did is they encapsulated ceramic, silicon carbide, inside of titanium. Because when you combine ceramic and metals, they have a different coefficient of expansion. Ceramic doesn't move across a broad temperature range. Metal, on the other hand, does. So if you lay them up together in a traditional configuration, you got a mismatch in CTE. And it breaks the bond between the silicon carbide and the metal substrate. When you encapsulate it, you hold everything together and you don't have that CTE mismatch. And so this was actually hit with a ballistic projectile at high speed to demonstrate its capability. That's why it's all mangled.
Wow. That's way cool. Titanium.
An interesting point about this technology if you think in terms of forgings and castings, maybe the supplier is offshore, maybe the supply chain is constrained, and it may take you 12 months to 18 months to get your part. You can print this in a matter of weeks.
So is the commercialization part of it, or is part of the mission, is to scale up a production using type of equipment like this?
It is possible. I mean, this facility is going to be early stage research and development, focusing on data generation, standards development, workforce development. Because when you have a sophisticated one-off machine like this, you can't just post a job and expect to have candidates that come in and know how to run it.
Right.
So we have to be mindful of workforce development, professional development along the path as well. So we have people in the space that know how to operate this machinery.
Great. And you would say someone like Macomb Community College or some other entity like that would be a great collaborator.
Absolutely.
Bringing students in and learning. Yeah.
And we're actually pursuing government grants to support professional development, not in just four-year universities with engineers, but vocational development as well.
Great.
The point is, when you're talking about additive manufacturing, there is a bias in terms of certification and part qualification. And there are different schools of thought. One school is more legacy thinking, that you need to have a different process, you need to take a different path to qualify parts if it's an additive part, versus just make sure that the part meets the requirements. It doesn't matter how you make it, whether it's a forging or a casting or a 3D printed, as long as it meets the requirements, it should be good to go. And there are people in the space like GE Additive who are actually making additive parts in production and putting them on aircraft engines and flying them. So there are people out there that are really moving the needle and solving the part qualification issue to really benefit the industry.
So when you talk about the qualification and because it's an additive or it's a part that's made on a machine like this, why would it make any difference? It's just because of the way the operation and the machine, it's kind of new and there's really no reference points throughout a long period of time. Is that kind of it?
I think additive manufacturing, especially in metallic systems, is early. It's very early in its development. And traditionally there may have been microvoids inside the part or inclusions or weaknesses in the part because it was 3D printed. They're starting to solve those challenges, and they're even starting to do in situ monitoring. So as you're printing, as long as all of your manufacturing parameters are within the spec or tolerance, you can be assured that your printed part is going to meet the requirements. So you print the part, you test the part to failure, and then correlate that past part to the manufacturing process, so that if you control your manufacturing process, you know you're going to get a good part. That's kind of the thought process.
Okay, cool. Hey, we're here today in Sterling Heights, Michigan, home of manufacturing, Detroit area manufacturing hub. And we're working on a session with Mark Pickett. Mark is with the SA Government Technologies Group, and it's great to have you here, Mark. What do you do? What do you do with this Government Technologies? It's a new thing to me, anyway.
Thank you, Mark. We launched SAE Government Technologies just over a year ago, and we wanted to expand the business model of collaborating with government, industry, and academia to solve technical challenges, especially in the modernization of tactical and combat vehicles with the U.S. Army.
So it's government or military side oriented, or is it the technology that you're working with here, because also applicable to commercialization, right?
Absolutely. So we're part of SAE ITC, which stands for Industry Technologies Consortia. SAE as an enterprise has about 15 different entities recognized by the IRS. And 12 of those are within SAE ITC, and they are consortium-based organizations. And so SAE Government Technologies has an OTA contract with the U.S. Army Development Command Ground Vehicle Systems Center here at the Detroit Arsenal. And the name of that consortium is DATSI, Defense Automotive Technology Consortium. And back in 2016, when we got under contract with the Army, the thought process was that we could be a conduit to translate automotive technologies into the defense space. And OTA contracts are organized stripped of FAR and DFAR regulations in order to go fast to facilitate prototype development. Typically, if the government saw technology in the automotive space that they found interesting, by the time they got on contract, it could be 12 to 18 months later and that technology was no longer relevant and probably obsolesced. So the OTA is quite an old contract mechanism used by NASA back in the 1950s to rapidly develop prototypes. And so DATSI is one of our programs, and I'm on the, I would say, business development side. And so I collaborate with Ground Vehicle Systems Center and the program offices at the Detroit Arsenal to bring projects to the consortium. We manage a consortium of about 200 companies, and we all collaborate on solving mobility challenges within the Army across 8 technology focus areas, such as cybersecurity, advanced energy storage, and safety systems, for example.
So we're here today, again, in Sterling Heights, Michigan. It's the Advanced Manufacturing Commercialization Center. That's where we're at today.
Right.
More details about what the technology here is all about in the center. Could you share a couple ideas of what you're working on?
Absolutely. And I think this came to fruition because we leveraged the relationship, the strong partnership we have with Ground Vehicle Systems Center. And the Army is going to print a jointless combat hull at scale at Rock Island Arsenal. And they're going to print that in metal. And so in order to get that manufacturing process correct, they need a pilot facility. And so we've been tapped on the shoulder to prop up a center where we have a pilot scale machine that's identical to the one that's going in at Rock Island. So we can leverage the use of that machine to generate relevant additive manufacturing data, where we can train workforce, we can develop standards, we can characterize raw materials, develop manufacturing processes, and most importantly, develop techniques to qualify parts to make sure that 3D printed metallic parts are going to work.
Well, tell me a little bit more about your ideas in the standardization efforts. I'm a standards guy, but I know nothing about metal or manufacturing, anything like that. Cybersecurity standards, yeah. OBD2 standards, yeah. Are there a lot of standards in this area? And SAE is probably already thinking about playing a big role in that, aren't they?
Yes, we have a aerospace material specification additive manufacturing data consortium. And that is a consortium of volunteer organizations that come together to coalesce to perform experiments and generate additive manufacturing data, especially in metallic parts. And they share that data across the consortium membership and industry to sort of raise the tide for all ships in the additive manufacturing space. And then that data is used to inform standards that are relevant to that manufacturing process or that raw material utilization or even part qualification. And so if you think in terms of supply chain innovation and additive, SAE is collaborating across its different entities to, again, bring value to that space, create data, inform standards, use facilities like this to do experimentation, research and development, and pilot scale work, and then collaborate in the space with other organizations and leverage Performance Review Institute, for example, that has programs to oversee supply chain to make sure that safety and quality are utmost performance levels.
Well, maybe a question or two going back to DATSI. That was interesting. Yesterday we were at an industry event where we started talking there. You were sharing information with other colleagues in the defense industry. The commercialization, bringing in these non-defense industry companies, large and small, really has an opportunity to bring great technology and accelerate what is coming into the U.S. Army and what they're trying to develop. The technology today takes years for government, I guess, to get it under contract. And that's part of your opportunity to accelerate that, right?
Absolutely. Probably nearly two-thirds of the membership of the DATSI consortium are small business or non-traditional defense contractors. And so there is a bias within the U.S. government that sometimes you find the most unique tech underneath the sofa cushions or underneath the kitchen rug. You've got to really look and search for those small, innovative companies. And some of those companies have no idea how to do business with the government, and that's where we come in. We can help simplify the acquisition process for them, introduce them to the right people within the government, present them with problem statements that then are relevant to their capabilities, and they can come to the table and collaborate with other consortium members to solve really tough challenges.
Well,
And just to make another point, I think you brought up the deliberate name of this center, Commercialization Center. That's really important. And it was deliberately named that way because the government, the U.S. Army, of course, wants to collaborate with us on this pilot facility for Rock Island Arsenal support. But the manufacturing techniques, the advanced manufacturing techniques that are developed in this center, they want those commercialized. They don't want those to be unique manufacturing techniques for the government because the government will not benefit with the economies of scale that happens when you commercialize a manufacturing technique that can be used broadly across both commercial applications as well as defense applications. So that's the point of the name of the center.
Wonderful. So if people wanted to get more information, they could reach out to you, I'm sure. They could Google the SAE DATC Consortium. I guess they come over here and visit with you sometime. It'd be great to see the facility and what you got going on. So I really appreciate all the time you've taken here to show us around and tell us about anything that, oh, one more thing, supply chain and recovery elements. That's new too. Can you talk about that real quick before we wrap up?
Yeah, that's our most recent consortium and program activity. We identified back in June of last year that critical materials and critical elements are important to national security in the defense supply chain, as well as aerospace supply chain. Some of those critical elements that are used in critical part fabrication, they're sourced in adversarial nations. And so if an adversarial nation wanted to get sideways with the United States, they could turn off that supply and we would be stuck not being able to find those raw materials to make those critical parts. So we formed a consortium to solve that. Our first grant was awarded to us by the Office of Local Defense Community Cooperation, where we are going to harvest scandium, which is important in high-performance aluminum alloys, from industrial waste streams in the United States. And it's economically competitive with the source in China. So not only is it going to provide a fully capable supply chain in the United States for scandium, it's also environmentally sustainable because we are extracting it from waste streams, industrial waste streams in the United States. And we're going to continue to go and solve those challenges for other critical elements, rare earth elements, for example, that are important for advanced energy storage and so on. We're going to continue to build out this capability.
Gosh, that's exciting. Well, again, thanks for joining, Mark. I really appreciate your time and learning more about all the different associations that SAE is involved in. It's like, oh man, more than just the standard stuff. And the SAE Detroit section is very pleased that you're located here within our regions.
Thank you, Mark.
Thanks again. Thanks, everybody. Well, have a great day, everybody. A supercharged day. Thanks for joining us. And if you need more information, please reach out to me and I'll put you in touch with the Manufacturing Center, Detroit section, and we'll see you next time.